4 point charges of equal magnitude are held at the corners of a square as shown below. The length of each side of the square is 2a and the sign of the charges is as shown. The point P is at the center of the square. Determine the magnitude of the electric field strength at point P due to one of the point charges. Okay. For finding the electric field strength, we always use the positive test charge. I put the positive test charge at the center of the square, and then you can concentrate on any of those charges. I can take it at the top right corner. And so let's take the distance between Q and P to be R. So generally E is K Q over R squared. Here I just substitute the values. In the numerator, the Q is Q, the capital Q, but the R. I should remind you something from geometry. If I have a square with sides of x, the diameter of this square is d, and you can find d as x square root of 2. Here the side of this square is 2a, so the diameter of this square is 2a square root of 2, and so r is half of diameter to be a square root of 2. So I substitute r for a square root of 2 to the power of 2. The answer is kq over 2a squared. Let's name it E1, the electric field due to one of the point charges at the corner. Let's continue. On a copy of the diagram above, draw an arrow to represent the direction of the resultant electric field at point P. Okay, resultant electric field will be the resultant of 4 point charges at the corners. So let's take positive Q and positive Q to be positive, and negative Q and negative Q negative as mentioned in the question. So again, as I put the positive test charge here, the positive Q on the right top right corner will repel that charge. Let's take it to be E1 as we have already found it. And also this negative Q will attract it with the same magnitude, same direction. This positive Q on the top left corner will repel that test charge with the same E1. And also this bottom right corner will attract it with the same magnitude, same direction, E1. The resultant electric field will be downwards, and let's name it E. 2E1 here and 2E1 here make a square, and so E, the resultant electric field, is going to be 2E1, the length of each side, multiplied by square root of 2. For triple I, determine that in terms of Q, A, and K, the magnitude of the electric field strength at point P. We just substitute the values. The E will be 2. Here E1 is something we used from the previous result. K Q over 2A squared. Then square root of 2. Okay, we can forget about these two. So E will be K Q square root of 2 over A squared. And this is the final answer.